Chapter 5, here we come. Using transformations to graph quadratic functions. The essential question of the day is, how can I transform quadratic functions? So look at what we have, Miss Boyd. A question. So I want you to think about this.
Okay.
I know you have your notes in front of you.
Right.
I get it. But can the path of a football kicked into the air be modeled with a linear function?
Well, think about it. We kick the ball,
Mm-hmm.
kick it, and then it comes down.
Does that form a line?
A straight line?
No.
No.
Exactly. That's what, when it says linear, is students may say, what's that mean? That means a straight line.
Yeah.
It's not a straight line. So let's look at the answer. Oh, no. The ball's path is curved. First the ball goes up and then it goes down. So notice what we're going to start using today. The ball's path can be modeled by a quadratic function, which is non-linear.
Okay.
That's what we're talking about in this chapter. Next page. Let's just review. Linear function means straight line. So f of x, if that confuses you, just means y equals mx plus b, in case. We have quadratic functions in standard form and quadratic functions in vertex form.
Okay.
There they are. Quadratic in standard is ax squared plus bx plus c, and vertex is a, and you can see that right in front of you. We're going to talk about this in the next example a little bit more.
You'll get it.
But that's the shape of a quadratic function, and the vertex of a quadratic function is always at 0, 0.
Okay.
Now, I think we pretty much covered that. Oh, maybe highlight one thing.
Okay.
Maybe highlight the parent function. Do you see where it says parent function? So the parent function is f of x equals x squared, or you can think of it as y equals x squared, and the vertex is at 0, 0. You must know the parent function because we're using that to do our to see how the graph moves. Okay. Exactly. So it is a U shape, and it's in the shape of the curve called a parabola.
Okay.
Now, we're not going to really do much here.
No.
All we're trying to demonstrate for you is there's an old-fashioned last resort way of graphing quadratic functions or any function using a table. What that means is you start with an input, which is your x value, you plug it into your function, and you get an output, which is a y value. And if I scroll down, all they did is plotted every single one of the points, connected the dots.
Okay.
Our method today is so much easier, Miss Boyd.
Quick and easy.
So let's talk about, I know here it says refer back to 2.6. We didn't teach 2.6, and that is all right. So what we're going to do is we're going to graph quadratic functions today by applying transformations. So maybe highlight the word transformations. Do you see that above?
Where?
Right there. See it?
Transforming?
Nope, right,
Oh boy.
right there.
Thank you.
See? We're going to graph using transformations. So what we're doing is we're transforming the parent function and transforming maybe just in parentheses. Moving. Yeah, can you write that? Because students get really confused on that. Just means moving. That's all. So let's talk about this. I'm going to go a little slower here because we haven't covered this yet. We have horizontal translations and we have vertical. So horizontal, maybe just right, means left or right. It's left or right movement. That's it. And if you notice, look at the graph, the blue is our parent function.
That's what we start with.
Right?
At 0, 0.
And the red is how we moved it. Now, what we're going to teach you today is anytime you have a function where you have part of the function in parentheses and then the squared, so notice this, you see the squared right there? You have parentheses and a squared. That is the h value. And I know it says x minus h. So what I want you to think of is h is opposite of what you think. So if you see a minus h, it's truly going to be a positive.
To the right.
To the right. And if you see a plus h, that means negative to the left. And with an example, I think it will be way more clear. So vertical is really easy because vertical refers to your k value and it's up or down. Now, one more thing. If, again, remember, h is what's in the parentheses, and then you have the squared, k is outside. So let's do our first example. Using the graph of that's our parent function. describe the transformation, then graph.
Okay.
So this is what I really need you to get in the habit of doing. When
Mhm.
it says describe, you're finding an H and you're finding a K first. That's first step.
Okay.
So the H, remember, is what's in the parentheses. I see a +2,
It's
so H is
really
going to be
supposed
a
to be
-2.
-2.
And our K is what you
Whatever
see
you
is
see.
what you
So
get.
it is -3.
Now, next to the H, when you have a negative H, that means you're going to the left 2. So let's write that, left 2. And K, negative, means down 3. So when I say describe, that's what I mean.
Okay,
Find
left,
H,
right,
find
up or
K, and write me words.
Okay.
But it also says to graph.
Yep.
So maybe for demonstration purposes on this first example,
Okay.
let's draw our parent function
Okay.
maybe first.
So I will start it just in
0, 0.
black. Yep. So
Yep.
start at 0, 0,
And
and
we're
you
gonna-
just make a U.
Mm-hmm.
And it doesn't have to be perfect.
No.
It just, oh boy.
That's
has
it.
to
That's
kind of look like
fine.
a U.
Okay. Now the new function means we're gonna go to the left 2. What that
So
means
we're
is you're
gonna start
starting
right.
at 0, 0. You're gonna move
Over
to the
2,
left 2 and then down 3.
3.
There's our new vertex.
There's our
Maybe
new
let's
vertex.
label that underneath, and the vertex is going to
Sure.
be -2, -3, and again you're going to create a U.
Okay. And it doesn't matter how it looks. Again,
Nope.
as long as it looks like a U, we're good.
That's all you need, and it's going to be an upward facing U, and I'll show you in a minute when it's
Right.
going to be upside down.
Okay.
That's example 1. Example 2. All right, same thing. I think we should go
Alright.
through this. All we should do is,
Well, there's nothing in parentheses this time. So do we have an H?
so guess what? We sure do, but the H is going to be equal to 0. So if you don't have parentheses, then you know the H is 0.
Okay.
The K is going to be,
Is what it is.
right, you see what's what
It's
you
gonna
get.
be -5.
-5. So let's do that. And now in
So,
parentheses, maybe you're going to go
down
down 5. Exactly.
Okay.
And H is 0, you're not moving left or
No.
right. So again, we started 0, 0. We don't have to plot
No.
the parent function.
Mm-mm.
And this time we're going to not go
1,
right or
2,
left. You're just
3,
going down,
4, 5,
right,
and make a U,
and there you go.
and you're done.
And you're done.
That's it.
All right.
Sweet.
Now, if we go, what I'm thinking is if we go and look at the next one,
Mhm.
do you want to
Skip
skip
it.
that
Yeah.
and do that in class? That's example 3.
Okay.
And example 4, do you feel we should
I
do
think we
one
will.
more, or should we skip this one?
We can do it quick.
Let's do it quick. Okay.
Because this one, look at this one, is a little different again.
Right.
It's got that plus.
Yes.
So remember, we do opposite
Of what you
so
think.
it's really a -3.
Yes.
And then here's our -2, which we keep what it is on the outside.
What you see is what you get.
And so -2. So
Exactly.
we're going to go back 3. 1, 2, 3.
Yep. And
Oh
down.
boy.
Oh.
Don't put it yet.
No. Back 3.
Back 3, down 2. There's
and then
our
plot.
dot, and plot.
And then maybe in parentheses,
Yep,
let's just
over
write
there.
left 3
Left 3,
and down
2.
2. And do we need to pause?
Sure.
Okay. So we're going to pause for a minute here, and we will be right back.
Sorry, my son woke up, so he's going to be in the video.
Yeah.
Anyways, so we're going to change this because Miss Young didn't like that I didn't hit my vertex perfectly.
No.
So we're going to make it
Oh, there.
go through. There we go.
Okay.
All right.
So now I'm going to scroll down. So we just talked about horizontal and vertical transformations.
Yes.
Now we're going to talk about reflecting across the y-axis, across the x-axis, and a vertical stretch and compression.
Okay.
What I want to highlight though is we will never be using in Algebra 2 horizontal stretches and compressions.
Oh, okay.
Only vertical.
Just vertical.
Yep, which are much easier to learn.
Yes, they are.
So when we talk about reflecting across the y-axis,
Mhm.
what I like to remember is what's changing here
Mhm.
is your
Your
x is changing. And think about it, that makes sense because you picture that in that picture there, you have a y-axis and that's the vertical. So you're
Mhm.
just flipping left or right, which is changing your x's.
Okay.
So maybe next to reflecting across the y, just say
Sure.
x changes. I like
Sure.
them to think of that. Here we go. And then reflecting across the y-axis means
The Y
changes.
changes.
And that's why the negative is outside.
Side of the
So then we'll
parentheses.
write y changes.
All right.
And then that's about it. And really, vertical stretching compression, the only thing I really want to mention is notice it talks about the absolute value. The reason that is is because if you have a negative sign in front of your A value, the negative has nothing to do with the A. The negative has to do with
flipping.
flipping.
Over the X or
If
Y
there is a
axis.
negative out front, that means we're
Gotcha.
flipping over the X axis actually.
Yep, yep.
Okay?
Yeah.
So if A is greater than 1, so the absolute value of A, that is called a stretch.
So it's going to make it bigger.
Yep. If A is actually a stretch, what a stretch means, it's going to make it skinnier. Skinnier. And I'll tell you, and I'll explain that in a minute. A compression means your A value is less than 1. So I think of a garbage dump. Okay. And I think of my garbage is so full every week that it's overflowing. Gotcha. So I picture myself getting in my garbage can and pushing down my garbage. I'm compressing my garbage. Gotcha. I'm pushing it down. So it's like pushing the graph closer to the X axis. Gotcha. When you do that, I think of C compress chunky. Your graph is getting fatter. You're getting chunky. And stretches, think of skinny. Your graph is getting skinnier. You're stretching it away from the x-axis. Got it. Stretch skinny. Does that help?
Yeah,
I think that's what I thought. All right, I think that's good. We go to let's do this example. Okay. So again, the parent functions, y equals x squared, and we're going to describe the transformation.
Okay, so I'm going to do the original one.
Please do.
Just so that we can kind of, and it's got to go through 0, 0.
Yes. All right. Now, notice here, I don't see parentheses.
I don't either.
That means h is equal to
0.
Right, h is equal to 0. And also, I don't have a plus or minus.
I don't either.
So k is 0. So guess what the only thing happening is?
The only thing is this negative sign, which flips it over the x-axis.
So that's what we want to write. We want to write, we just say reflect over x-axis. And I need to see these words. Reflect over or flip over, whatever. Reflect over x-axis. That's what the negative is. So maybe, and then the other one is the 1/2. Let's talk about the 1/2.
Yeah.
The 1/2 means compress.
Compress.
Yep, compress by 1/2. That's all they have to write. Compress by 1/2. So let's talk about this.
Compress, C, chunky, so it's going to be fatter.
Yeah, because it's less. Thank you.
Thank
you. So yeah, now I'm confusing myself because it's less than 1.
So
yes,
flipping and
it's getting fatter, chunky. Yep. Right. So the negative means flip, and the 1/2 means get fatter.
Got it.
Are we good?
Yeah.
Now, should we do this one or should we maybe skip it?
Kind of like the
one
we just
so
did.
let's skip it. Let's go on to the next page. Okay, this is the last part of the lesson.
Okay.
So in the first part of the lesson, we gave you a function and we said find h, find k, find, and basically describe the transformation. That's what we said. Now we're going to go the opposite direction and we're going to describe the transformation and you have to give us the function.
Okay.
Okay?
Yeah.
We know the parent function. So right here, let's talk about this a minute because this is important. If a parabola opens upward, it has a lowest point. And so if a parabola opens downward, it obviously then has a highest point.
Okay.
The lowest or highest point occurs at the vertex.
Which makes sense.
Which makes sense of the parabola. And now maybe highlight, I'm going to float down for you. Do you see where it says vertex form? Maybe highlight this one down here.
Okay.
The vertex form is what you're going to use right now in this part of the lesson. So again, A is your stretch or your compression.
Right.
H is your right or left, opposite of what you think.
Yep.
And K is your up or down. That's all I want to talk about. So let's go to, it might help to go through a couple of these because these are kind of tricky. So use the description to write the quadratic function in vertex form. So let's write what vertex form is again. Remember, it's going to be, in this case, we're creating a G. So let's call it G of X. If you want to call it L, M, N, N, O, whatever you want to call it, you can call it. But we're going to call it G of X. So let's say G of X is equal to A, and then in parentheses, X minus H, square that, plus K. There we go. So let's write what we know. F of X equals X squared is reflected, it should say reflected, across the x-axis. So right away, negative. And translate 5 units left. So guess what? That's our h. Yes. So h is equal to -5.
-5.
Yep.
Yes.
So maybe write h equals. There we go. Okay. And 1 unit up. So k is equal to?
K is +1.
Right. So guess what? We're going to plug it in.
Okay.
So g of x, we're going to write
G of x
is equal to. Now, we don't have an a.
No.
It didn't say stretch or compress, but we do need the
It's
negative out
reflecting,
there.
so
So
it's just
negative.
negative.
And then in parentheses, it's x minus, and
negative
so
5.
maybe in parentheses, write -5. This is where they get confused. And
Yes.
square that whole thing. You need one more little parenthesis after that -5.
thank
See
you.
that?
Yep.
Plus
Plus
1. So let's fix this.
Yeah.
Or finish it, I
sloppy.
should say. G of x is equal to negative. Instead of x minus, it's x plus.
5 squared.
Right.
Plus 1.
However, if you don't want to go through those extra steps that we just did, if you can remember h, it's always opposite of what you think. So look, we see a plus 5, so we know, oh, h is -5. It's always opposite of what you think. So there you go. Should we try number 2? Because it's
I think we
vertically
should almost just save these
for class.
'cause we're already
Oh,
at 15
you know
minutes.
what? I totally agree with you. Let's go. Let's go to the next screen then. Your video
All right.
questions, number 1 and number 2. Number 2, be very careful. It says use H and K. So what I want to see is, I want, you don't have to tell me what your H or K are. What I want to see is when it says describe the transformation, tell me, is it going to the right, to the left, how many
down,
units,
flipped.
up, down, flipped, whatever. I
Okay.
want those words.
Sounds good.